everybody, and welcome to JS Monthly, our April event. This is our 13th virtual event. So we had to make, as everybody knows, we had to make a transfer from in-person events to virtual events. And we know that you've all been really patient with us. And we hope that in the next couple of months, as the measures slowly start to ease down, that we are going to be able to see you in person. I imagine that everybody just can't wait to do that. But this virtual meetups are giving us an opportunity for people to join us from different continents and from different parts of the world. So, for an example, we have today with us Shruti joining us from, if I'm correct, New York.
California.
All right, I'm sorry about that.
No worries.
We have Shruti that's going to be talking about GraphQL misconceptions and what actually GraphQL isn't. So loads of us actually know, and when we start learning technologies, we actually learn what are they good for, but sometimes we are not aware of the reasons what shouldn't we use that technology for. So Shruti is gonna shed a bit of light when it comes to that about GraphQL. And after Shruti, we are going to have Matteo Collina talking about multithreading in JavaScript and their specific example at how they moved their log processing from the main thread to a separate thread, something that most of us do not have an opportunity to encounter, but it's definitely an interesting thing and interesting subject to listen to. For those of you who do not know me, my name is Milos, and I've been with JS Monthly London for a couple of years now. If you want to talk at JS Monthly, and if you have experience or do not have any experience, you can just drop us a message at jsmonthly.london@gmail.com or just contact me via Twitter at happy_fist, and we'll be really happy to help you out with getting your talk ready for our meetup. I'm just going to go quickly over the agenda for tonight's meetup. So in 1 minute, we are going to start with Shruti's talk, GraphQL misconceptions. The talk is supposed to end around 6:45, and then we're going to have a short Q&A with Shruti. So if you have any question, just type them into the YouTube comment section, or if you're on a Zoom call, just type them into the chat, and I'll make sure to copy that over and read through them to Shruti. Then we're going to have a 10-minute break, and after that we're going to have Matteo Collina talking about multithreading in JavaScript. We'd like to say big thank you to Pusher, which is the company that has been our sponsor for quite a while now, and without them we would not be able to continue organizing this virtual meetups. If you have any questions for JS Monthly, about JS Monthly, or about what are we doing and about what kind of talks we accept, or anything else regarding meetups, just make sure you drop us a message at JS Monthly London at Twitter. And if you're making any tweets about us, make sure that you use JS Monthly online hashtag. Thank you, and that's it from me. I'm going to pass over the mic to Shruti.
Thanks, Milos. Okay, let me share my screen. Can you see my screen? Cool. Am I good to get started? Awesome. Hey, everyone. Thank you for coming to this meetup. And thank you, Milos and Alex, for hosting me. I am going to talk about what is in GraphQL today, and I will be talking about it from a misconceptions point of view. Um, Before I get started, I want to introduce myself. Give me 1 second. My name is Shruti Kapoor, and I am in sunny California, in USA, in San Francisco. You can find me on Twitter at Shruti Kapoor08 or on Twitch at Shruti Kapoor. And I host co-working live sessions where I invite people to bring their side projects so we can all work together, stay motivated. Um, I work at PayPal as a senior software engineer, and I've been working with GraphQL for over 3 years now. When I first started with GraphQL, there was a lot of questions I had in my mind, and I could not find those answers anywhere. For example, like is GraphQL similar to Graph, or what is the QL in GraphQL? And through this presentation, I want to help answer those questions for you guys if you have those questions, and I want to solve any misconceptions that you may have. If you're interested in more talks like this or more blog articles like this or about GraphQL or JavaScript in general, you can follow me on Twitter where I share out any blog posts and articles that I made. And if you've been following me on Twitter, you know that I aggressively tweet dev jokes. So of course, we have to have dev jokes today as well. So I'm going to ask you a question and then you can answer it in the chat. I'll look at the chat here to see your answers as well. So first question. Where do programmers hang out? Let me open the chat here. So where do programmers hang out? Both. We don't. That is true. Well, we hang out at meetups, right? We hang out at Foo Bar. Oh yeah, that's correct. That is correct too. But Foo Bar. Okay, next one. How did HTML get drunk? It had too many BR.
That's a good one.
What did the developer say to the Git repository? Fork you. No worries. If you wanna, uh, oh yeah, you'll need beer when you're writing CSS. But yeah, if you want to look at more dev jokes, read more dev jokes, you can find them on GitHub. There is a repository called github.com/shrutikapur08/dev joke. But anyways, let's get started. So today I'm going to talk about what is in GraphQL, and specifically, I will dive. Okay, give me 1 second. There we go. Specifically, I will dive deep into what is GraphQL versus REST and give a brief introduction of how GraphQL and REST are different. We'll look at some misconceptions, 10 misconceptions. We'll talk about some good things from my personal experience. And if you are interested in GraphQL, how you can get started. So the first thing, let's talk a little bit about what is GraphQL versus REST and how it compares. So for the purpose of this presentation, I'm going to be going over this example. Let's say that we're building a library app and we want to show the title of the book and the author of the book. So we're only interested in two fields. The title could be a string. The title would be a string, and then the author could be an array of strings. So there could be one or more authors. And so that's the structure of the data that we're looking at. So let's say that we are building an app where we just want to show the title of the book and the author, one or two authors. If this is an app that we're building, there's usually like 4 to 5 different steps in building an app. The first step is we need to think about what data we want to send to the server. So what data should we get back? What data are we supposed to send? So like, for example, IDs and things like that. In the REST world, we'll look at the API documentation and we'll find out which routes we need to call, which methods are available. So for example, if you may have found out that there is an endpoint called books, there's an endpoint called authors, and that endpoint can be useful to us. In GraphQL, instead, before looking at the documentation, we have to think about what data we need. So in this example, we're building a library app. We need the book and the author. So those are the two fields that we need. The next step is that now we know what data we need to send. Now we have to create a request. So in the REST world, we have our endpoint books and authors. We have to find out what does books and author accept. So they may be accepting an ID, they may be accepting a string or things like that. So you have to find out which parameters the endpoint accepts. In GraphQL, we have an endpoint / GraphQL, and that's the only endpoint we have. So we don't have like separate /book / author endpoint. We just have the one endpoint. And in order to get the data, we need to first create a query of fields that we need. So for example, here we'll need the title of the book. So we have a query of field called title, and then we need the name of the author. So we'll have author name. So now we know what data we need to send. The next step is to figure out in REST which verb we are going to use. So we could have a get or a post or a patch, a delete or put. In GraphQL, there would be either a query or a mutation. So query is when we need to get the data. It's similar to REST get. And mutation is the job of post, patch, delete, and put. Okay, so now we know that we need, let's say, query. And in REST, we need get to fetch the data. We've got the IDs, we've got the fields that we need to send. The next step is on the server side, we need to make sure that we've got the methods that can handle that, right? So we've got retrieve authors that accepts an author ID, sends back the author. We've got retrieve books that accepts a book ID, sends back the book. Similarly, in the GraphQL case, on the server side, we need to make sure that we've got the resolver for the query that we are accepting. So for example, if we've got a field coming in, which is book or title, we need to make sure that we've got a resolver. So resolver is similar to the resource implementation in REST. It's basically just a function that helps you send back the data for the field that was requested. So if you've got title, that function may do something like fetch it from the database or call another endpoint or like call another REST API in case it's an orchestration layer. So resolver does the magic of finding which data to send. So now at the server side, we built our server implementation. The next part is we have to send that data back. And on the client side, we need to parse that received data. So in REST world, we usually get a JSON object, but we also get fields that may not be the ones that we're looking for. So if we ask for title, there may be other fields that we have not requested. Whereas in GraphQL, because you requested for the data, you only get back the data that you asked for, and which is a really powerful thing about GraphQL. So you also get back a JSON object, but you only get the data that you had asked for. Now let's look at some of the myths that people have had about GraphQL. Like any professional engineer, I did my research on Twitter, and I asked people, tell me some misconceptions that you had with GraphQL. And the most common misconceptions are, I narrowed the list down to 10 misconceptions, and the most common misconceptions are here. The first misconception that most people have is that GraphQL is similar to Graph, or that GraphQL is similar to the SQL because of the QL. Also, another misconception is that it only works with graph type data. And I think maybe because of the way we present GraphQL, it feels that GraphQL does the magic of fetching data automatically. Another thing I think that a lot of people have is that with GraphQL, you don't need to manage your data on the client side, or like you don't need Redux. And that REST and GraphQL can't coexist because GraphQL is very different from REST. And because it feels that GraphQL is so difficult to onboard, it feels a lot of people have the misconception that GraphQL is really difficult to introduce in an existing project. So let's look at some of these misconceptions in detail. Let's first talk about the one that's most commonly found, which is that GraphQL is similar to Graph. And the misconception here usually that people have is that it's somehow related to like D3JS, or it's kind of similar to the Facebook's Graph. But actually, the graph in GraphQL works for data that looks or feels like a graph. So for example, here we have the book. The book has a title. The title is a string. So this way we are drawing the connection between the data. We're drawing the graph between data. And that's what the graph in GraphQL represents. Another example is that you may have a book and you may have the book's author. Then the author has also written a bunch of other books. So you're looking at book, then you're fetching author, then you're also fetching another books list from that author. So this way you're kind of like drawing the relationship between the different fields. And that's what the graph in GraphQL represents. So the misconception may be that it only works for graph-like structures, but it actually works for any data that can be expressed in terms of nodes and how they connect. So here we looked at books and we have the title. So a book may have like the title may be like name or email or bio, but we're only interested in name. So that's the field that we'll use to draw a relationship in. The next misconception is that GraphQL is similar to SQL. And I think that's probably because of the QL in GraphQL. And a lot of people have misconception that it's kind of like another query language for databases, and that we may have to do something like select star, something like that, like a query language. But actually, the query language of GraphQL kind of means that this is just a way for asking for data. So you don't write select star or whatever, but you just say it's kind of like a way of asking for the title pragmatic programmer. Um, and the QL here represents asking the data from the API. So GraphQL is a query language for an API. It's not a database language. You can implement your database in whatever language you want. Your database may still be in a SQL type language. But GraphQL is just built on top of that to fetch data from the API, from the database. There are, however, libraries like dgraph that are all the way GraphQL at the database level as well, but it's not mandatory to have GraphQL at the database level. Another common misconception, like we talked, is that it works magically, that if you just pass a query and with the title book, with the field book or title, that the data would come back magically. But just like in REST, you also have to write, similarly in GraphQL, you also have to write the implementation on the server side. And for GraphQL, this is done in a resolver. So you'll write all the APIs that you need to call within that resolver. You'll write all the database queries that you need to do in that resolver. The resolver is kind of similar to the resource implementation in REST. And I think another very common misconception is that GraphQL replaces Redux. And I think this may be because GraphQL already reduces the need for having a state management library. So a common misconception that people have said is that GraphQL replaces Redux. So why bother having something like Redux or even React hooks? But the thing is that GraphQL is just a way for asking for data. And once you have that data on the client side, you still need to manage it. GraphQL reduces the data that comes back to the client. So you may not need a heavy state management library like Redux, but depending on how much data you get back from the API, you still have to manage that data. And you can use whichever library you want. You may be able to just get away with React hooks, or you can use the default state management that comes from Apollo client, or you may have to use a heavier state management library like Redux, but you still have data that you need to manage on the client side. A very common misconception is that with GraphQL, you have to like strip everything down. You can't have any REST microservices. You can't have REST with GraphQL. But actually, because GraphQL works really beautifully as an orchestration layer, one of the most powerful things of GraphQL is that you can have your existing architecture as is, and you can just build GraphQL on top of it. So you build GraphQL as an orchestration layer that in turn just talks to REST APIs. But for your client, they're just seeing one endpoint. So they're just seeing that the GraphQL endpoint. So you still get the benefits of having a GraphQL endpoint, whereas you can still keep your existing microservices architecture. That's a great thing about GraphQL. A lot of companies have also implemented GraphQL in parallel with REST. So they have the REST implementations for REST endpoints for whatever's existing, but everything that's new is going in GraphQL. So you can totally have GraphQL with REST or on top of REST. Um, one library that does this kind of orchestration really well is OneGraph. And it's a really cool way of selecting multiple API endpoints. So they have examples of like Spotify or GitHub, dev.to, and then you can kind of pick and choose whichever library, whichever endpoint you want, and then you can have that come up in your GraphQL endpoint. So you're not doing any sort of like integrations, but OneGraph does that kind of like magic stitching of data for you. So it's really cool. Check it out if you're interested in that kind of like orchestration. Um, Another misconception that kind of follows from the same microservices architecture is that it's difficult to introduce an existing project. And this was one misconception that we commonly had when we were starting to adopt GraphQL in PayPal, because a lot of people thought that it's kind of like an all or nothing, and you need to replace everything that you have in your REST API in order to introduce GraphQL in your project, or that it's only meant for like greenfield projects, something that's completely new. But the thing with GraphQL is that because it works really well as an orchestration layer, you can kind of pick and choose whichever endpoint you want. So you can start with a small endpoint that doesn't have maybe a lot of audience, doesn't have a lot of stake, and you can kind of convert that into GraphQL, and you can slowly start migrating your app one endpoint at a time. Another really common misconception is that GraphQL is only for like JavaScript or only for front-end folks or only for libraries that use React. But the great beauty of GraphQL actually lies on the backend, because you're able to only send the data back that the client needs. And that's amazing because on the back end, you can add fields to the existing API without having to deprecate, because there's only one endpoint, there's only the GraphQL endpoint. You can add fields without having to change the version, or you can intelligently look at which fields are being used so that you can either deprecate it if you need to, or add a deprecate flag, or see the instrumentation on that field. So you can see how many people are using a particular field. So I think the real beauty of GraphQL comes from the backend. Another common misconception is that GraphQL will write database queries itself, that you just need to take care of the query or the mutation, but everything behind this happens itself. But the thing is, like, again, GraphQL is similar to how REST has a resource implementation. So you still need to do all the magic of doing your database queries in your resolvers, unless if you're using a library like Prisma or Neo4j that kind of does this for you. Another really common misconception is that you need to have like a really big client like Apollo or something to have GraphQL in your project. But the thing is that GraphQL is actually just a curl command. People think that in order to get GraphQL, you need to like build a GraphQL server, it requires a third-party client. But because GraphQL is just like an HTTP request, it's just an HTTP API, you can just do a curl command, just like how you would do with the REST. So for example, here we've got the curl command, and then the only thing you need to worry about is the data, because we have to fetch for the fields. We have to fetch for which field we need. So you can pass that fields in the data, the data part, and you can fetch the exact field that you need, but then pass in your GraphQL endpoint as the endpoint. So to sum up, the 10 myths that we looked at was GraphQL is similar to Graph or SQL. We looked at why GraphQL only, we looked at the misconception that GraphQL only works with graph type data, that data fetching works magically, or that GraphQL replaces Redux, REST and GraphQL can't coexist, and GraphQL is difficult to introduce in an existing project. GraphQL is only useful for front end and it will write database queries itself, or that it requires complicated clients. So from my personal perspective, I really like GraphQL because I've been using it a lot on the front end and now a lot on the back end as well. And I think the best thing that it worked for us was that as a front end developer, GraphQL gives you type definition for free. So as a front-end developer, I don't need to do the validation of the data. So for example, if I say that title is a string, and then if a client passes, let's say, a number for that field, GraphQL will automatically throw an error there. So as a front-end developer, that reduces the validation that I need to do on client's data. And at PayPal, one of the great things about introducing GraphQL was that it brought our front end and back end teams together because we have to establish a schema at the beginning of the project itself. We sat down together and we discussed all the fields that we need. And our schema was then driven by our UI instead of being driven by what data we need to send, instead of like blindly sending that data back. So it increased the collaborations between our team, and it brought our teams together because we set up a contract in the beginning itself. And then that also helped us to independently work and intelligently work on our APIs, on our front end and back end bit independently. Another cool thing about GraphQL of introducing it on the backend was that it gave us powerful instrumentation of the data, and specifically to a field level. So the data is super granular, and that helped us understand which fields were being used, so that the fields that were not being used, we could intelligently deprecate them. An amazing thing about GraphQL is that because you're only getting back the fields that you asked for, it helps to reduce overfetching of data and underfetching of data. Overfetching of data means that you're getting too much fields, and underfetching means that you didn't get the field that you needed, so you have to make another request. And because with GraphQL, you can ask for everything that you need in one go. You don't have to do multiple routes. And an amazing thing about GraphQL, especially at PayPal, was that because there's one endpoint, we can keep pushing updates as often as we need to, and we don't have to worry about increasing the versions or changing versions or deprecating versions or like introducing breaking changes. So if you like GraphQL and you want to get started with GraphQL, here are some common places to get started. I think another amazing place is the GraphQL docs, official docs itself, which is on graphql.org. It has a list of FAQs as well, which is really amazing for kind of like a follow-up of this talk if you're interested. Apollo Docs, Apollo is actually one of the libraries that is used for implementing GraphQL on the front end, on the back end. Apollo has amazing docs as well. And then Prisma has a docs, which is kind of like a quiz-based approach of learning GraphQL, which I found really helpful. It's on howtographql.com. When we were introducing GraphQL to our teams at PayPal, the first thing we would show them is graphical tool, which is this tool here. And this is kind of like an interactive way of fetch data. And this was really helpful in kind of showing the power of GraphQL and the dev tools around it. So if you're interested in checking out GraphQL or graphical, you can find it here on GitHub. There's also lots of great tutorials as well. Egghead has a lot of good GraphQL resources. There's an amazing book by Eve Parcello and Alex Banks on learning GraphQL, which is a very good introduction of GraphQL. There's also courses on Udemy. The specific one that I really like is by Stephen Grider. It's called GraphQL with React. And it was very helpful for me to introduce GraphQL in my current architecture at PayPal. If you're interested in getting started with GraphQL, I've also written a blog post that you can find on my GitHub on github.com/ShrutiKapoor08/blogs. And it's an introduction of like what is GraphQL and how it differs from REST, things like that. So to sum up, today we talked about 4 things. We talked about what is GraphQL versus REST, the misconceptions, some cool things that we liked of GraphQL at PayPal, and how you can get started. Before I end the presentation, I also want to share something that I'm doing today. Some of you may be aware of the crisis that's going on in India related to COVID. The country is breaking down, the system is breaking down. So I am doing a fundraiser today at 9 p.m. to 11 p.m. PST, which may be tomorrow for you guys, on my twitch.tv/Shruti Kapoor. And basically, I invite you all to donate whatever little you can to a foundation for helping COVID relief in India. But also, in addition to everything that you'll donate, I'll also donate $1 per viewer. So I encourage you to join. You're helping out just by being there. And I want to end the presentation with one final dev joke. Thank you, everybody. You've been an amazing audience.
Thank you very much. Thank you.
Am I live? All right, perfect. Thank you, Shruti, very much. That was an amazing talk.
Thank you.
I think that we are ready for some Q&A. Alex, are we ready for that? Perfect. Is that like everything that you wanted to say? And we can start with a Q&A, Shruti.
Let's do it.
All right, perfect. There's a couple of questions that came through. Like the first one that like I'd like to know. So I'm going to use this opportunity to ask a question for myself. Do you think that it would be easier to like for somebody to understand like GraphQL without prior knowledge to like without having any experience with SQL languages, like without having any like database specific experiences?
Yeah, totally. Yeah, so GraphQL is actually very different from SQL. So in that sense, it's really good if you are very new to SQL or don't have much experience with SQL. It kind of abstracts all of that away. And if you need to write SQL queries, you can still write them, but you don't need to have any prior knowledge of it.
Perfect. We have one question coming in from Prince. The question is coming from YouTube. How to handle images in GraphQL?
Oh, that's a great question. So that depends on like where your image is hosted. If you've got image like in a URL, it works the same way. Things like file uploads, that's not developed just yet, but have something existing, you can kind of use that as is. But if you have like a URL, that works the same way.
All right, sounds good. Like, are you able to, like you mentioned, like using resolvers to control like how the data flows? Is it possible to use those resolvers to somehow like write the image stream to a file or something?
Yeah, like totally we can do that. The only thing is like you need to think about how like what the type of the field would be. So something like JSON could work. Yeah, the only thing is like how you're going to have that type. But then once you receive the data, you can use your resolver to stream that over to wherever you need to.
Okay, sounds good. All right, let's go to the next question. Why did you decide to like introduce GraphQL? Like, is PayPal the place where you like first encountered GraphQL? Like, what was the reason behind the decision to like start going with something like GraphQL? If you're able
Yeah,
to
that's a
answer that
great
for us.
question. Yeah, that's a great question. Actually, so I gave a talk at the CityJS conference about the same topic. But to summarize, I will say when we were looking at GraphQL, before that, we had a few problems that we were facing as a company. One of them was, so we had so many endpoints. The whole like concept of finding which endpoint we need to use was really hard. Like the explorability of the resource endpoint that we need was a big challenge that we were facing at the company, just because of the sheer scale of the massive endpoints that we have. That was one big problem. Another big problem was that we kept introducing versions, and it would break the client sometimes because we don't know if like a field was being used by a client, and then we maybe don't introduce it in another version, then we have a breaking change and we can't force the client to update and things like that. So like introducing versions or like deprecating fields, that became a really big problem to us. Because we were blind to that kind of instrumentation, we didn't really know, like we didn't really make those intelligent updates, so to say. So those were the two biggest problems that we were facing. And then at that time, GraphQL, like because of those two problems, GraphQL just seemed like the perfect solution for that, because you have like with GraphQL's inspector, you have the entirety of mutations and queries available to you. You can also like query them on the fly and see what's in the data. So yeah, so those were the two big reasons we introduced GraphQL.
Okay, sounds good. Like it all makes sense. We have the next question asking when to use GraphQL and when not to use it. So like, is there any specific case where like you would not recommend GraphQL, or like a specific example where you've seen people using it where they shouldn't?
Yeah, totally. I think one of the places that people may be using GraphQL where they shouldn't is when you kind of have REST API doing the exact same thing that GraphQL needs to do, and so there's like a one-to-one mapping between your GraphQL and REST API. So, for example, in the example that we were looking at, let's say that you've got title and author, and that's exactly what the REST API is giving you. So it's only giving you two fields. But then, in order to just like use GraphQL, you built an orchestration layer on top of REST. So you're just like duplicating everything that's going on in REST in your GraphQL. At that point, you're kind of not leveraging the use of GraphQL, which is like underfetching and overfetching. So at that point, you're just like increasing the work for you, and GraphQL is not like, then it's no point using GraphQL at that point, just to do like a one-to-one mapping between REST and GraphQL. So that's one big thing, big mistake that we've kind of made at PayPal as well in some applications that can be avoided. Another thing is like before introducing GraphQL, maybe think about like what the challenges are in your organization. There's a lot of things that GraphQL, because it's like a new technology, it's still evolving. There's a lot of things that are not developed yet. So some things like error handling, authentication, authorizations, file uploads, that kind of stuff is like still being worked on. So maybe think about like what challenges you are facing and if GraphQL would be a good technology to use.
All right, that's great. Is there any situation that you like to mention where like you think that you tripped because you chose the use of GraphQL in PayPal?
Yeah, so I think one of the places where, so like I was saying, right, like error handling is not built very well in GraphQL. So if you are unfamiliar, I'll just give a brief intro of that. So basically what happens is like with an HTTP request, like a REST request, you get a 500 back or you get like a 400 back, and then you'll have like a 422, right? So you'll know like what happened, and with 400s and 420s, you already know what happens. You can kind of like intelligently show it in your form. And so I was building an application where I had to extensively use error fields or like error that would come back and kind of like modify my form that way. But then with GraphQL, because everything is a 200, it's an HTTP request, but everything comes back as a 200. So you kind of have to dig down further in the error objects to find out what actually happened, maybe downstream from the REST API. So even if your GraphQL is giving you a 200, there may still be an error. So you have to look at the error objects. But then for my case, I was like doing even further deep dive into that error objects to find out exactly what error I need to show and like what error message I need to show. So it became really complicated, just like dealing and parsing all of that errors with GraphQL at that point. So yeah, like error validation, error handling is still not developed in GraphQL.
All right, like that sounds good. I think that there's like one or two more questions. Would you, like you mentioned at some point that like you can use GraphQL on front end and use it on the back end too. Like for somebody who's just starting out, what would you recommend, like to try it out on the front end or on the back end?
Yeah, that's a great question. I'd first recommend that you try out GraphQL with the tools that are that kind of help you fetch and like get a taste of GraphQL. So like Graphical is one, Playground is one, and you can actually connect it to open GraphQL API. Spotify has one, and GitHub has one. So what you can do is connect Graphical or Playground to an open API, so you can kind of get your hands dirty with GraphQL, how to fire query, how to fire mutations, things like that. And once you've done that, then the next progression from there is to adopt GraphQL on the front end so that you can kind of build an app that is already consuming GraphQL data. And then once you're comfortable using GraphQL on the front end, then you can move on to the back end where you actually build the server and you build that API that sends the server that information.
Okay, sounds good. I think that this is actually, I think just one more question came through YouTube. Does the team size has any impact on usage of GraphQL?
No, the team size doesn't have any impact. The smaller teams is better because there's more collaboration. When we started, my team had I think 7 people, and yeah, so the smaller teams is better just because collaboration is easier, making a contract is easier. But at PayPal, almost all teams are using GraphQL, and there's almost like 500 teams that are using GraphQL now.
Yeah. Do you think that it will maybe be easier for somebody like example, having a company like PayPal, which is a big company. Imagine that like your code base is quite big, and like your GraphQL, like the possibilities that you can do with GraphQL are pretty big. Like, do you think it would be easier to introduce a new person like to GraphQL, or to like the example where you previously had just like REST API?
Yeah, that's a great question. So I feel like if somebody is not familiar with REST, it would still be a good fundamental place to start, just so you can understand the basics of API, how REST works, the mutation, the verbs, and all of that. I think REST is still a great place to start. If somebody is completely new to the company and GraphQL is already being used, I would still give them like a small microservice to work on that they can convert to GraphQL. So maybe like work incrementally one step at a time. But I still feel that REST is a good fundamental to have before getting started with GraphQL.
Okay, that's perfect. Maybe like one last thing. Do you have your favorite dev joke on you and ready to tell us now? Or we already heard it?
Okay, my favorite is how do you comfort a JavaScript bug?
All right, no clue.
You console it.
All right, that was a good one. I need to start using that GitHub page with dev jokes. All right, that was amazing, Shruti. Thank you very much once again, like for joining us, and like for sharing all of this knowledge with us. There's one more thing that I forgot to mention in the introduction, and that is that CityJS conference, which is partly organized by JS Monthly crew, is also wants to like help out people of India. So we created a GoFund. Actually, it's Giving India. I think the company that organizes the fundraiser for the people from India suffering from COVID. And if any of you currently watching us is interested in helping out, we are going to send the link for the fundraiser in the YouTube and here on Zoom chat. So that like if any of you is interested in helping out, you can just use that link and do what we can to help people out. We are going to have a short break. I think that we're going to be back in about 15 minutes with Matteo's talk about JavaScript and multithreading. That's it from me. See you in a bit. Hi all, and welcome back to the second part of 13th JS Monthly Online Meetup. For the next talk, we're going to have Matteo Collina talking about multi-threading in JavaScript and how him and his company moved the logging process from the main thread to a separate thread. Enjoy.
Hi, London. I'm so happy to be back here speaking at your meetup after the conference and a bunch of other things. To be honest, I really love this was a real meetup because I can't wait to meet all of you in person. And yeah, I can't wait to be back in the city. It has been more than a year, and I start to get a little bit of cabin fever, and I would really love to be back traveling and meeting you all. Anyway, before we start, I just want to thank for having me tonight. Anyway, um, before we start, who I am Matteo Collina. At Matteo Collina on Twitter, you might know me from conference, interwebs, whatever. If you're not, you haven't ever heard of me, follow me on Twitter, pretty please. And yay. What else about me? I'm part of the Node.js Technical Steering Committee, the team that maintains Node.js. I'm also I'm also the co-creator of Fastify and Pino. I'm work at Nearform as a title as technical director. I'm also a software architect and engineering consultant. So I help companies shipping Node.js. Please follow my newsletter, Adventures in Nodeland, at nodeland.dev. It's I think it's kind of nice, but you might want to decide. You might want to decide for yourself. But check it out. A lot of people have been enjoying it for the last few issues. Um, Apparently, I am a 6 billion download person. I don't know what that means. If I got 1 cent for each one of those downloads, I will be pretty rich. I'm not getting any, so I don't know. Okay, well, let's get started anyway with the talk. Well, before we go, it's what I'm doing in my role at Nearform. I tend to balance between helping people using Node.js, and working as a consultant with maintaining the ecosystem. So this is always this unstable balance, but it's kind of unique in that sense. So it's a company I really like. By the way, Nearform here, you can see it here. We are hiring quite a lot, both permanent and contractor roles in the UK and beyond. So just check us out, nearform.com/careers if you are interested. So we are here today to talk about Pino, the fastest logger for Node.js. It has, I don't know, maybe minimal features and a great community. It's been downloaded quite a lot, to be honest. I don't remember if it's like last time I checked, it was 5 millions, probably 6 now. I don't know. Hopefully, we can probably check. Like, I don't know if you ever checked this live, but there is this nice website called npm stat where you can go and check how many downloads you are getting, and it's 6.5 million downloads per month in March. So yeah, I should update my slides. Hey, happy days. Pino is doing great. It's growing really well, to be honest. It's like this is Christmas. Look at Christmas. So nice. Everybody's on vacation. So anyway, Pino has 4 collaborators and it has version 6. However, we are here to talk about version 7. So this talk, it's really about version 7. Let's do a quick refresher on how Pino works. So Pino is this nice logger that produce JSON and produce new line delimited JSON. So it's a JSON on a line, very simple. And you can just create Pino and you can just use the logger to log things out. So you can have the concept of child loggers, which are pretty common. So this is the very simple part of the talk finished. Let me do a quick demo of Pino first, so that now we can talk about Pino 7 and what has changed. So let me switch to the cool. Here we are. So here we are. So Pino. Now we can, this is called example. So let's open the example, okay? And if we open the example, you can do node example, and you see you get all those lines. Whoa. How can we read them? Well, you can actually read them by using Pino Pretty. And with this, you get a nice output. Cool. Okay. So you've seen how this work. Okay. You've seen that in order to format our logs, we actually connect it to another post processors that, make them pretty nice or change the format. We can have, for example, Pino Elasticsearch to send them to Elasticsearch, for example. Okay, so in production, you will probably use something like Elasticsearch. I was very lazy, so I didn't build much slides, but I have some diagrams sketched on my iPad. So let's see how we can see it. Okay, cool. So these are my diagrams for Pino v7. So what we have in the iPad? Well, in the iPad we have you can see that we have this concept of the previous transport, which essentially we were recommending people to run the transports off process, so in a separate process. Why? So you will not block the main event loop to deal with logs. As much as logs are important, the job of our applications is to respond to their clients. So we don't want to block the event loop, block the response, or create additional load to send your logs to Elasticsearch, for example. However, this type of transport system, for example, using Unix pipes, was very complex to run and deploy. Typically, when we run them on the cloud, in fact, what I was recommending was that you run your Node app as a Docker container, and these went log into the Docker logs that then sent to for example, with FileBeat, you could get them to Elasticsearch as before, and Kibana, and then you could access them from Kibana. Pretty neat. However, you could also use, for example, AWS CloudWatch. That was also good as well. Cool. Okay. So these add a few issues though, because for a lot of people running like Node, loading up piping two system together, it was not really useful. They complained a lot. They wanted to run things at the same thing on the same process. So, this was also a feature that was supported by Bunyan, it was supported by Winston, and a lot of people coming from those loggers, they really wanted this feature in. And we always recommended against it because essentially we did not want to create too much burden on the main thread that was also already very busy responding to your clients. The typical behavior when you're doing all these operations in the logger, by the way, it's a huge spike in memory. So essentially, when you were running these type of things in memory, you will see that the memory usage was actually spiking to the roof, which was really, really bad. So what did we do? Well, what we did was we thought about this problem and how to provide a better user experience. And we actually divided this concept of the new transports. So new transports, what do they do? Well, it's inside the same node process, you have your main thread when your main application runs, as well as the worker thread, and then a worker thread where we run all your log processing. This is pretty neat because we can actually differentiate so that we can do a lot of log things in the secondary thread and not block the event loop in the main one unless we really want to. So all of these things can actually work in tandem and produce a extremely good, um, really good developer experience as well as really good performance. So how does this work? Well, I'm glad you asked. And this is David McClemen's quote. So thank you, Dave. Let's go back to my slides. And so the first thing that I wanted to show you is a new tiny module called Pino.js ThreadStream. ThreadStream, it's a very simple module. This it's essentially you can create your stream, and you require your stream. You create your stream, and then you just specify the file name, the full path of a worker file. This file is going to be used as the worker thread, and we can actually pass in some data in, some options, some more stuff, and this behaves like a string. It has the same API of a string, apart that it only accepts strings. So inside your worker file, you just need to export a single async function where you can just create your destinations, and that's it. That's how you set it up. Okay. However, you can support a lot more complex scenario now that you can run things separately. Note that it supports both synchronous and asynchronous flashing, so that whenever one of the tricky bits of the system is that whenever your process is crashing, you might not have a full event loop running. So you might need to do, as it says, a flush or a flash sync. And those things are actually supported by this library, which is pretty neat. So how does this work? Okay, I just wanted to show you briefly. And let's go back to the code. Okay, so in here, let's see an example. So this is a very simple example that creates a new thread stream. Use join, pass in some worker data, and which processor V is the input from my command line. And then when the stream is ready, we write some stuff to it, and then we call flash sync, and then we are ref. So hey, happy days. So that the process can actually exit. Okay, let's start this. So if I do node create and exit London, here we go. Okay, did nothing, but if we cat London, you'll see that there is hello world. Okay, so I can actually remove London. Cool, right? It's pretty nice. What's in that file? So, well, this is the file that you can use, and it's the same one that it was in the README. And as you can see, we can just create it and call run. Pretty neat, again. Note that you can actually use ECMAScript modules if you like them. So you can literally create import and use your import and export to do the exact same thing that you were doing before without them. So if you prefer this syntax, you can use this syntax as well. Cool. How are you going to use these in Pino? And this is what type of user experience we would like to provide. So okay, let's see an example. So in this new release of Pino, so let's open up the transports. So in this new release of Pino, we create a new logger with called a multi-transport thing. Maybe this API might change a little. This thing is not released yet. I'm talking about pre-release code. I hope you are as excited about it as I am, so that you can contribute and check it out. So what do? We create our logger with pulsing this multi-transport concept, and we pass in two transports. One, we want to send all the log with level 1 to a file, and all the log with level info to with a pretty printer. So standard output with some pretty printing outfit. So that, by the way, this is we don't recommend use pretty print in production because it will block the event loop in a not needed way. To be honest, with worker thread, if you have CPU system to spare, probably not is not going to make a lot of harm. But still, don't do it because it will be more costly than what you would usually want it to be. So let's keep going. We create those two things. We do some logging, and then the process exits. Okay. So what do? We do node example transports, you will see that all the output get out. And we got a new log, big log line here, big log file. And I'm going to cut this file. As you see, it has only error and npx pretty print. And yeah, yeah, that was probably not a good idea. Come on. Really good. Okay. So as you can see, it only contains those. Cool. Okay. So we can rerun this and it will just work as expected. Note that it is a very interesting part to say. So if we open it up, and at the very end of the script, we do console log example finished, you will see that it actually print example finished at the very first line. Why? Because all the others are being done in the secondary thread, which needs a couple of event loop cycle to be started up and so on before writing it. So hey, just so that you are aware of it, there is that is actually important. So how is this? You might wonder how is this implemented internally, and this is something that I really want to show you because it's actually pretty easy. So in here, what we have, we have the worker. This is the same worker of the ThreadStream worker, and what this does, it's essentially it performs some simple stream manipulation to assemble a multi-stream, which is still something that we support in Pino, and it will, it's used to assemble a bunch of streams together as a single destination. So that's what it is. As again, you see a bunch of to-dos because I haven't finished working on this topic just yet. So so this is actually pretty simple in the sense that we do some initialization, then we return a function, then use called build on this Pino abstract transport. Whoa, what does Pino abstract transport do? Well, Pino abstract transform here we go. Oh, maybe the readme is better. Okay, what does Pino abstract transform do? Well, Pino abstract transform essentially it runs a function build that it simplifies writing transports. It makes writing them pretty easily. So essentially, it combines split2 to process and parse the incoming new line delimited delimited JSON. So how is this implemented? Well, let's see. It's actually very straightforward. We use split2 and we create to parse the stream, and then for each line we try to parse the JSON, create objects, set some metadata, and that's it essentially. So pretty great, and it's something that works really well. So we can combine lots of things together, and you will be able to use this utility to write your own transports if you want so. So it's pretty neat. Uh, some other very important bits that I would like to cover before I wrap up is how the ThreadStream is implemented. In order to do so, I will need my iPad because I'm going to draw. I need to draw something. Okay, so let's hope the demo gods of writing follow me. So here we go. Ooh, iPad Pro. Cool. Okay. So you have So you have, so ThreadStream, ThreadStream is built on the concept of it's called a ring buffer. How it works? It works that you have 2 pointers. Okay, so you have 2 pointers, which says this is the write pointer and the read pointer. So the one. So let's say that at any given time we have written till here, okay, and then the read pointer would be here, for example. Okay, oh no, this is probably not a good color. Here, okay. So at any given time, we know how much the worker thread will have to read. So essentially, in this situation, when the worker thread wakes up, it knows, oh, I have essentially all this area here to read. This is one of the key parts of how ThreadStream work. So essentially, we maintain those data. It maintains this data structure to be able to constantly synchronize the two streams without never blocking. So they can actually never block. Well, that's not true. It can when it needs they block when they need to cycle the ring buffer. So then when it needs to start with the fresh one and move to the previous one, so start from scratch. But anyway, this is pretty great from my point of view because we can actually um, you know, it can communicate between those two streams, those two threads without mostly never block. By default, this is I think 4 MB area, which is big enough. You can even make it bigger if you want to. There is also some activity that can be done to improve the efficiency of this data structure, but maybe maybe they won't be made in time for the Pino v7 release. So if you're interested in playing with atomics and this kind of work, like please came back, came back, and I can we can actually have some fun together. Just wanted to show you a couple of more things. I wanted to show a couple of more things of this library, and here we go. So okay, so as you can see, we have uh, as you can see, this it has quite a long piece of code, but one of the interesting bit is the use of atomics weight. And as you can see, we do atomics load and atomics weight. So with atomics weight, we wait on this read index for this value, for this value to change, So it's pretty great. It's pretty great, to be honest. Okay, I love it. And on the other end, we do a notify. And when we do a notify, we don't notify to wake up. How we set up the worker thread? Well, we use const worker and we get the worker thread, and it's pretty neat because we can just do new worker to execute is the file to execute, and then we pass in the option. On the other end, what we do, we have our worker implementation, and this is what gets executed in the worker thread, and we import your function, your file name, and it creates a little bit of all our state stuff, and then we receive a post message, and then we start running. And in running, we just read your the red index we do some wait diff, which is some asynchronous magic, but we don't. It's pretty interesting things again that are happening because the platform still does not have all the things that we need. So essentially, there is not a wait async operator, whatever. Anyway, and then we write up until we can. So here we go. I just wanted to show this. Thank you very much for watching and staying with me with this for this talk tonight. Thank you for your time, and please follow me on Twitter at Matteo Collina, and as I said, nearfrom.com /careers. We are hiring quite a lot, all sort of positions. So you might want to join us. And remember also to go to nodeland.dev and subscribe. So just saying thank you very much. My DMs are open in case you have any questions, also on Twitter, whatever. Bye bye.
All right. Matteo, thank you very much for joining us at our 13JS monthly virtual meetup. That was a phenomenal talk. For any of you that are interested in asking any questions to Matteo, you're welcome to drop him a message on Twitter, and Matteo will be willing to answer all those questions. Unfortunately, he was not able to join us for in-person Q&A due to some personal reasons. I'd like to thank you all for coming and for listening to us tonight. We had two really amazing talks. We haven't seen each other in a while, but we hope that in next couple of months the things are gonna relax and the measures are gonna ease up enough so that all of us can actually have a really nice in-person event and just hang out as we did before all of this pandemic thing started. There's two more things that I want to mention. Again, huge thanks to Pusher for sponsoring us and for sticking up with us for this whole pandemic and helping us organize all of these virtual meetups. And the second thing that I want to mention once again is that as Shruti has said previously, India is going through a really rough time, one of the worst hit countries with the COVID. They're having a new wave coming in, and they're really having it hard. So if any of you is interested in helping out CityJS organizing a fundraiser, you can find the link on our YouTube channel, actually on this YouTube video in the comment section, or on our meetup page. Again in the comment section. That's it for us. Once again, big thank you for joining us, and I hope that we're going to see you next month. Thank you and bye.